Hi, everyone. Welcome. We're going to give everyone just another minute or two to get into the webinar, and then we'll get started. Thanks again for joining us, everyone. We're going to give it just another minute. We had quite a few folks signing up at the last minute to attend today. Well, welcome, everyone. We're going to go ahead and get started. Welcome to the first installment of 2024 for Water with Your Lunch. This episode of Know Your Snow is an exciting one. We're here in partnership with Water Education Colorado. Caitlin Coleman represents Water Education Colorado, and I'll let her introduce herself in just a minute. My name's Lindsay DeFreitas. I'm the Deputy Director of Public Relations at the Colorado River District. As a reminder, in the webinar format, we have the chat feature disabled, but please put in your thoughts, questions that you want to have answered at the end of the presentations into the Q&A feature, and we'll be able to access those. And after all of our panelists have had a minute to talk through their information, they'll be available for those questions at the end of the program. You'll see that you're muted, and we are looking forward to addressing all questions again at the end of all of our panelists, but don't forget to add them in as you think about them. I wanted to just take a quick minute to introduce my organization to those of you who may not be familiar. I represent the Colorado River District. We are a government agency that represents the water users of the 15 counties on the western slope of Colorado. We're funded entirely by property taxes, and we were established in 1937 as a way of uniting the voices of water users scattered across the basins of the Yampa White Green, the Colorado River, and the Gunnison and the Uncompahgre as well. And our mission continues today to help protect, develop, and conserve those water resources on the western slope. We do that in a variety of ways. Our team is about 25 people, and we have different groups that interact with water users, whether on the technical side with our engineers who provide technical assistance, as well as facilitating collaboration between different groups. We have policy that works with legislators and decision makers to make sure that our voices are represented in those rooms where decisions are being made. We have a legal team who carefully examines the decisions in water court to make sure that the interests of West Slope water are being adequately represented. And we have information and outreach, things like today, where we take time to share important information with our constituents and to hear from them on the issues that are important to them. We also have a grant program called the Community Funding Partnership Program, and that provides small and large grants to water projects on the western slope of Colorado, and so far has successfully funded over 100 projects. And we also leveraged federal and state and other partnership dollars to make sure that those projects are getting off the ground and supporting our water users in developing resiliency as we move forward through hotter, drier climate changes. You can see in this map that we represent a significant portion of the headwaters of the Colorado River throughout the entire basin. One estimate is that the snow that is still on the mountains and that you'll hear more about today provides approximately 65% of the flows that go into Lee Ferry. But I will leave further discussion about the snowpack to our experts, and I'm going to hand it over to Caitlin to introduce herself, Water Education Colorado, which we are excited to be partnering with in this endeavor.
Thanks, Lindsay. I'm Caitlin Coleman. I'm Water Education Colorado's Publications and Digital Resources Managing Editor. And we're really excited to partner with the Colorado River District also to bring you today's presentation. If you're not familiar with Water Education Colorado, we work across the state and with folks outside of the state to inform and engage Coloradans on water issues. We do this through all different leadership trainings, educational resources, and programming to ensure that Coloradans are knowledgeable about key water issues and equipped to make smart decisions for a sustainable water future. In addition to programming like in-person or online programming like today's webinar, or Water with Your Lunch, I work on our publications, including Headwaters Magazine, which is our flagship publication. Our latest copy here with me. But that's one of the reasons why we're partnering today to present this program. We're getting ready to print and publish our spring issue of Headwaters, and it will be a snow issue. So if you're interested in learning more and diving more into snow-related topics, after our conversation today, we cover everything from cloud seeding to forecasting to solving the mystery of disappearing snowpack and new research around data collection. So stay tuned or become a WECO member to get on the magazine mailing list. And that brings us to today's wonderful topic as we get to better know our snow. Of course, our April 1st snowpack and streamflow forecasts are out. So we're going to learn how things are looking for our rivers this year. Why are these forecasts so critical? Why have recent forecasts sometimes overestimated the snow to flow connection? And what are the other factors at play that can lead to a gap between deep winter snows and low summer flows? Got some brilliant speakers here today to walk us through all of this. First, we'll hear from Brendan Langenheisen, who's the Director of Technical Advocacy for the Colorado River Water Conservation District and oversees Colorado intrastate engineering matters such as water rights, water resource stewardship, and river administration. Brendan serves as the technical lead advocate for the district regarding Trans Mountain diverters, representing the 15 West Slope counties that rely on rivers flowing through their basins of origin. Brendan has been with the district since October 2020. He is a licensed engineer and holds a bachelor's degree in civil engineering from Gonzaga University. Next, we'll hear from Paul Miller, who's the service coordination hydrologist at the Colorado Basin River Forecast Center, where he's been for about 9 years. Prior to joining the Forecast Center, he worked for the Bureau of Reclamation in the Boulder Canyon Operations Office for about 7 years. He received his PhD in Civil and Environmental Engineering from the University of Nevada, Las Vegas, where he studied the impacts of climate change to the Colorado River Basin, in part through the use of CBRFC hydrologic models and projected temperature and precipitation data sets. Then we'll hear a joint presentation from Peter Goebel and Elise Osenga. Peter Goebel is the climatologist with the Colorado State University Climate Center. There he supports the Climate Center's 3 main missions of climate research, data collection, and education outreach. He received his bachelor's degree in meteorology from the University of Northern Colorado in 2012 and his master's in atmospheric science from CSU in 2016. His current research includes using machine learning to better understand errors in annual water supply forecasts in Colorado and using a mix of observed and modeled data to determine where we can grow more wine grapes in Colorado now and in the future. Peter is the state coordinator for the Community Collaborative Rain, Hail, and Snow Network, or COCORAS. And Elise is the Community Science Manager with the Aspen Global Change Institute. Guided by her interests in ecosystem processes and the interface between science and public action, Elise's current projects include managing AGCI's Soil Moisture Monitoring Network, assisting in coordination of their fellowship program, and engaging with the local community to better understand how science can help them address challenges posed by a warming climate and other global changes. With that, unless Lindsay has anything more to say, I think we'll jump into hearing from Brendan.
Thanks, Caitlin.
Hi, great. Thank you for the introduction. And I'm really excited to be here today with all these great speakers. I'm just briefly going to go over the status of our snowpack right now and just give an update, kind of set the scene for everyone else as they go into their presentations. Again, my name is Brendan Langenheisen. I'm the Director of Technical Advocacy here at the Colorado River District. So the headlines for this year, it's good. It's not amazing, but it is pretty good. We're sitting really close to or just slightly above average snowpack all across the state. This was a really typical El Nino year where we had those big snow and precipitation events coming down through the southern part of the US. And you can see that here in this graphic over on the right. We are, as I said, above average snowpack in all the major basins. And we'll go into that a little bit more. Our reservoir levels are in really good shape, above average. And we have had some dust on snow occurrences that I'll briefly touch upon as well. Okay, so our snowpack, we had a really dry start. It was really slow as we started the year off. And you can see that kind of on this graph on the left. When we started off in November, December, we're down below average, below that median, down into even brushing up against the 10th percentile of snowpack. But come with the new year, also came some new snow and some new patterns, and it pushed us right up there, up to above that 30th percentile. And we've stayed there, and it's just gotten better all through the year. So this black line is really showing the history of where we are this year, this 2024 water year. And we're right up there, right above the average snow water equivalent levels. And you can see a better breakdown of each of the basins in Colorado, all our major basins, and all across the board, we're above 100%, which is fantastic. So it's great to see this. We love to see our snowpack in this level. Going down into finer detail, you can see some of the sub-basins across the state with our snowpack. Overall, it looks great, above 100%, even up into the 140s down in the southeast. But we also see some dry areas over on the Grand Mesa. On the west slope, that's one of the drier areas right now. But still, overall, not bad. We've seen a lot worse in the last couple years. In those 20s, 21, 22, 23 years, or not 23, 23 was a big year, but 2021 were both really drier years. So it's nice to see this. I like this pattern a lot more than those previous dry years. What we've seen since, this is just going back to the beginning of January. So these are some plots looking, and this is from the Colorado Climate Center. But trying to tell the story of, we've had some really warm temperatures across the state over these last 3 months, but we also have had a lot of really high moisture precipitation. So looking on the left, you could see really dry, particularly on the west slope in those lower elevations, but really kind of a warm across the whole state in general. The middle chart shows precip. The darker colors are getting into wetter conditions, and you can see a lot of those really big storms that came in, dropping 4 feet of snow on the Front Range. That's showing up on this graph, and that really tells a story and where we're at. with some of our snowpack, but also with our reservoir levels. And I'll get into that in a little bit. This last graph that I wanted to show on the far right is a grid that kind of shows where we are on precip and temperature. And so the further to the right you get, the more precip there is, and the further up you go in the chart, the warmer it is. And so there's a star there for 2024. That's where across the state we've ended up for this water year so far, from between March or October through March. And so we're setting up, and we're in this warm and wet kind of quartile of these years. So definitely matches with what we've kind of seen over the last 3 months. Getting into some of our reservoir levels, across the state, we are sitting really high in reservoir levels. And this is a comparison real quick. The blue is our current year levels. The green is last year's levels. As you can see, we're across the state, we're above where we were last year, but that holds true over average levels too. Particularly, I've highlighted the Arkansas, the Colorado headwaters, and the South Platte. These are some of the areas that we'll jump into in just a little bit, but you can see that these levels are significantly higher and are really setting us up for a really good runoff with those reservoirs full. That means a lot more water less water is needed to fill those, and more water can flow down those rivers and be available. I guess, so yeah, let's go to this next one. Looking at the west slope reservoirs. So each of these points kind of identifies a different reservoir, and I know they're just using initials here, but we have Granby Reservoir and Willow Creek up on the far right at the top of the Colorado River. We have Williams Fork a little bit lower on the Colorado, and Wolford Mountain Reservoir coming off the Muddy Creek there. On the blue, you have Green Mountain Reservoir and Dillon Reservoir. And then further down on this map, you see Homestake Reservoir and Rudeye. So this is just some of the reservoirs on the west slope, but it kind of shows you how each one of those is sitting as far as their percentages of average of storage. And I want to talk just briefly about some of these like Granby Reservoir and Williams Fork Reservoir, Wolford. All of these reservoirs are really sitting very well this year, and that has to do to a lot of different situations that have lined up. Last year being a really wet year allowed that there wasn't significant calls down on the river that they had to make releases to. That certainly has helped. The Cameo irrigation call didn't really was very limited in the amount that it called last year. We didn't have the Shoshone plant really calling last year either. There were shop operations, which is the Shoshone outage protocol. But because of that also impacted the reservoir levels. We also had a really wet spring last year too, where a lot of the trans mountain diversions, a lot of the background for the need for these reservoirs was to supply the Front Range. But when there was so much rain last spring in 2023, those diversions didn't need to happen. There was a call was taken off, and there was free river conditions on the Front Range for weeks. And so that has really led to some of these reservoirs being full. And the fourth situation that's kind of led to this too is that there's been a lot of maintenance and ongoing construction projects related to some of these trans mountain diversions. Granby Reservoir, the Adams Tunnel has been down for some maintenance for throughout the winter. And that's a time when they usually divert a lot of water from Granby over to the Front Range, and that hasn't occurred with that tunnel being down. And so has started, it's back and operating, and water's being moved out, but that has certainly elevated that reservoir into really high levels. And so that's kind of setting us up on this west slope for some good runoff. We have had some dust on snow events, and for those who don't know what dust on snow is, there's two pictures here. This is a picture of Utah on the left. Utah and Arizona is where a lot of this dust comes from when we get these big windstorms, these big flows coming through, or or big winds coming through, it'll pick up that wind and it deposits some on the mountains. And that's that other picture on the right. On top of that snow can then lead to faster melt. It warms up the snow. And each of these storms, as a new storm comes, that dust layer can get buried. But as it starts to melt, those dust layers start to compound on top of each other, expediting the melt. And we have had some storms. This is most recently, the storm was April 5th through the 7th, where we had winds over 80 miles an hour that really picked up a lot of dust. Early March was another one of those big storms. And this is a picture from the Center for Snow and Avalanche Studies. That was before the April snowstorm or dust on snow. This was from the March event. But you can really see all the dust deposits here, particularly on the west side of the states, over on the Grand Mesa and down in the southwest portion of the state. McClure Pass also had a lot of dust as well. So that was another one mentioned. But you see the shading of the snow, this really dusty color. And then as you go more east, it gets a little more clean to that white color. This other picture on the far right kind of shows how this dust layer is setting up. And again, this is a picture from before this most recent event. Just a few days ago. And that kind of concludes what kind of the status of our snow. I did just want to mention that the River District is a strong supporter of a lot of these snow sciences. We have provided a lot of funding for the CASM, the Colorado Airborne Snow Monitoring program. And in here, you can see this first graphic shows in blue, that's the snow surveys for 2024. That's going to be occurring through that program this year. And so we certainly have supported that and will continue to do that. We've also helped with some soil moisture monitoring network funding, both in the Roaring Fork area with Aspen Global Change Institute, as well as up in the Yampa Basin with the Yampa Valley Sustainability Council. So, and finally, we've also provided, we work in cooperation with the USGS and many partners within our district to fund some stream flow gauges and currently have over 20 gauges that we have funded and keep live on so that we can monitor those flows and understand how that snow melt comes down and shows up in our rivers. So with that, I will conclude.
Thanks, Brendan, for that overview. I appreciate it. It has been an interesting winter. I think all of us were a little disappointed with how it started, but it seems to be trying to make up for some lost ground there with these late storms. I keep expecting it to get really warm, and I hope that we can see some of that soon, but not too soon. And to talk a little bit more about how that snowpack is going to turn into the water in our rivers, I'd like to introduce Paul Miller. He is our next speaker, and he's the Service Coordination Hydrologist at the Colorado Basin River Forecast Center. So, Paul, thank you so much for being here.
Yeah, thanks, Lindsay, and thanks for that introduction and great first presentation there. I think it sets everything up really nicely. Can you see my slides okay? Okay, great. So, like Lindsay said, I'm the Service Coordination Hydrologist at the Colorado River Basin Forecast Center. That's really just a fancy way of saying that I'm the outreach guy. So if you have any questions about our products or services or ways that we can help you, definitely let me know. Definitely feel free to reach out. It's literally my job, and if no one calls, they just let me go. So not really. But so I work for the Colorado Basin River Forecast Center. We're one of, for those of you that aren't familiar with us, we're one of 13 river forecast centers that cover the entire nation, including Alaska and Hawaii. Like our name implies, we cover the entire Colorado River Basin and the eastern half of the Great Basin that basically lets us cover all of Utah. We're co-located with the Salt Lake City Weather Forecast Office, and you can see all the weather forecast offices that cover the continental United States there. But we're all about decision support. So basically everything we're doing, all our forecasts that we're making, we're doing that with the intention that it's being used in someone's decision-making process, or it's being used for us to help somebody with their decision-making process. So everything we do on our website, and we try not to make forecasts just for the sake of making forecasts. We really want them to be applicable and for folks to make actionable decisions on those. So here's kind of a zoom in of our area. For a lot of you, for kind of local issues related to weather or flooding concerns or that sort of thing, you might want to reach out to, for instance, the weather forecast office in Grand Junction or in Pueblo. But we're kind of the go-to source for stream flow forecasts. So if you have any questions about stream flow rates or forecasted snow melt in your area or water supply volumes, I think we're the go-to person. So like I mentioned, the weather forecast offices are a key stakeholder. We help them with their flood forecast. So if you're getting a notification on your phone about warning you about flood event or anything like that, we're in the background helping them figure out what the peak of that flood is going to be like, what the duration of that flood is going to be like. But they're the ones kind of working more directly with the emergency managers and those kinds of things. We work a lot with the water agencies and the water managers. So the Bureau of Reclamation, Denver Water, the Colorado River Conservation District in Colorado. We work with all of those folks. So we're a really great resource, I think, when it comes to stream flow and water supply forecasts. And again, definitely reach out if we can help you with anything. Over our area, we make forecasts at about 500 points every day. You can kind of see the map of those on the left there. Those are all those blue dots. These are short-term forecasts that are deterministic for the most part as of now, looking out about 10 days. On the right, you're going to see our water supply forecasts. We make those at a subset at about 175. These are seasonal. And when I say that, I mean the April through July period, because that's typically the snowmelt runoff period. Water supply forecast. So we're providing a volume mostly for reservoir operators so that they can get a sense of how much water they might see coming into their reservoirs, and they can make those decisions on how to manage that water, whether they need to hold back water, release water early, anything like that. But we're constantly working to improve these forecasts and incorporate the latest and greatest information. So I really want to stress that we are data consumers. We don't have our own gauge networks. We don't have our own system that we go out there and measure it. We're not in the field very often or at all. But we do use a lot of observed data. We use a ton of streamflow data from the USGS. And I think Colorado is really unique in that the state has a really great stream gauging network that we use. We also use the NRCS SNOTEL networks. Those are really important for us. Reservoir operation data from the Bureau of Reclamation and others. Forecasted weather and operations from our National Weather Service partners and our reservoir operators. And then we can look at this model and interact with it in all kinds of ways. So there's all kinds of model parameters and information that we're working with. And then we look at all of those 500 points at least once a day. So, and especially during snowmelt, it's going to be multiple times a day, but at least once a day, someone's putting eyes on it. Somebody's taking a look at how it's doing. We take an immense amount of data. It's a huge part of our job. We probably spend the first 2 hours every morning just going through and making sure that precip and temperature data looks okay and stream gauge information looks okay, and that our model is representing conditions as well as we can possibly get them to look. So there's lots of impacts made by these forecasts, particularly with regards to water resource and reservoir management. Like I said, the Bureau of Reclamation is a big consumer of our products and services. They take a lot of our forecast information and put it into their hydrologic models and their reservoir operation models so that they can decide how much water they need to release for hydropower generation, recreational demands, environmental demands, and of course, meeting water supply requirements by agricultural and municipal users. So big impacts. There was a study out of Arizona State University not too long ago that estimated it's about $2 billion in economic impacts. and that study was done a few years ago. So I imagine it's probably climbed up a bit since then. So how do we do all of this? How do we come up with some of these forecasts? So the way we do that is we take all of that data that I mentioned earlier, we put it into our hydrologic model, and we look at that observed data that's coming out at the stream gauge locations, and we say, hey, are we accurately capturing the hydrologic characteristics of the system over the last 10 days or so? And we tweak our models so that we make sure that we are accurately capturing the hydrologic state of the system. And from there, we go through and we recycle through historical precipitation and temperature traces. So today's April 11th. It's my wife's birthday. So we start from today and we say, okay, what does April 11th all the way through the end of the runoff season look like for 1991 for precip and temperatures? So 1991, we go through and we see what the model does with those precip and temperatures. Then we do 1992, 1993, 1994, all the way through 2020. So we come up with these 30 future traces of possible future hydrologies. We don't do any fancy weighting. We don't weight it with regards to El Nino or any other kind of teleconnections. But we provide this range of possible hydrologic futures so that we can give reservoir managers and other resource managers an idea of the risk and chances and probabilities that they might see as they're going through their operations. So this is what it looks like. The shaded area is that ensemble or that envelope of those 30 traces that I showed you. And that blue line is just that median value through those traces. We update this every day. Currently, we're forecasting about 87% of average inflow into Lake Powell this year. That's pretty good because typically after we have like a really wet year like we did last year, we've followed it up with these really, really dry years. So the fact that we're kind of sort of close to normal conditions this year, I think is really great for the system. But we can explain this graphic in more detail if you have any questions. So I wanted to talk a little bit about the uncertainty involved in our forecasts. There's a lot of, I would say, misunderstood information out there when it comes to some of the emerging technologies that are coming online. There's some claims, that you're going to get like 99% accurate forecasts if you just use our data. And that's really difficult to achieve or look at. So we took a look at the uncertainty and the error involved in our water supply forecasts. And there's model error because, of course, our model is not capturing, every finite detail that goes into the hydrologic system or the water cycle at every point in space over the entire Colorado River Basin. So there's lots of errors involved in just how the assumptions we make with regards to soil moisture and snowpack and parameters and how we assume that the system is working. So we looked at 35 years worth of data, and you can pretty much break up the error into two categories. Errors in the unknown future, the unknown weather. We have pretty good weather forecasts that go out about 10 days, but past that, it gets very uncertain. And then there's model error, and that's what I'm talking about with these different parameters. So even if we could get data that accurately and 100% captured everything we know about the system today, that would only take care of that model errors, which is about half of where our error comes from. And so here's a few points kind of scattered through, and you can see it would account for about, half of our overall model error if we were to be able to 100% accurately quantify the exact hydrologic state of the system. The rest, though, spring precipitation, we live in a highly variable hydroclimatic system. And there's just a lot of uncertainty with regards to future error. We've also sort of seen this argument that our forecasts are getting worse over time, whether that's in regards to data degradation or climate change or anything like that. So we went ahead and kind of did an analysis of our forecasts over time. And at the 95% confidence interval, our forecasts are generally not getting better or worse. They're staying the same, at least as of April. You can kind of see with these other trends that are shown on the left. There's a couple areas that are a little worse, especially in the San Juan, where things have gotten notably drier in January. But aside from that, generally our forecast trends have remained pretty steady. We show all the verification statistics with regards to our water supply forecast. Typically at this point of time in the year, we're within 10 to 15% of the volumetric runoff that you're going to see over the water supply period, which I think is pretty good. You'll see some of the warmer colors. Those are areas that are a bit more data sparse, and that's where we tend to struggle a little bit more. So where do we go from here? We're working with all kinds of partners to look at new data like ASO and CHASM, new models that are coming out, especially with regards to snow. All kinds of new methods, AI and machine learning methods are becoming way more prevalent. And we're a big active partner in the Colorado River Climate and Hydrology Work Group, where we prioritize a lot of these research topics and leverage funding from a lot of groups to get some of these gaps filled. Here's just an example of an experimental product that we send out. This is showing what our forecast would be if we were to incorporate remotely sensed LiDAR data, like from the Airborne Snow Observatory Network. And in a lot of areas, the results so far have been inconsistent. We just don't have a ton of data points. So sometimes it helps our forecast, sometimes it doesn't help our forecast, and everything in between. But that's a really quick overview of what we do at the CBRC. If you have any questions, please feel free to reach out. There's my email and our website. And with that, I'll turn it over to Lindsay.
Thanks so much, Paul. Paul kind of set up our next speakers pretty well. We're going to look at some of the specific impacts on the forecast, and we're going to zoom in a little bit. So Peter Benegobel is with the CSU Climate Center and Elise Sosenga with the Aspen Global Change Institute. And they're going to take a minute to look at some work that they're doing surrounding soil moisture and some local projects to gather that data. So thank you both for being here.
Yeah, thanks so much, Lindsay. All right, so we heard from our first speaker, Brendan, about how we have pretty near normal or even a little bit above normal snowpack as of April 1st. And so what I want to talk about for just a few minutes here before handing things over to Elise is why normal snowpack, especially around April 1st, doesn't always produce normal stream flow. And if you were listening during Paul's talk, he actually covered that quite nicely, where future weather was a major concern, where you really can't take your eye off the ball on April 1st. What happens in April through June or even April through July will impact the stream flows that we see over that time frame. So this is just an example from 2020 to motivate the research. So here on the left-hand panel, we're looking at the April 1st percent of 1991 through 2020 normal snowpack that we had in 2020. And we see that we are, if anything, a little bit above normal, not quite at that 100% mark in the Gunnison Basin. But if you look around at the Rio Grande Basin, the Colorado Mainstem, and the Yampa Basin, we're a little bit above that normal mark. Now, the middle panel is the forecasted April through July runoff on April 1st from the National Resources Conservation Service. So not Paul's office, but the NRCS. Both of them do seasonal stream flow forecasts. And you can see to an extent they're on top of things with not forecasting normal April through July runoff, despite having near normal April 1 snowpack. But if you go over to the farthest right panel, we're looking at the observed percent of normal April through July runoff in each of these river basins. And as you can see, in every case in 2020 anyway, it was below normal, and in every case, it was even lower than the forecast. And we saw that in 2021 as well. And so that made a number of waves in the media. And one of the things that kept coming up is, are dry soils to blame? If you look at the previous summers before each of these seasons, summer and fall, both 2019 and 2020, summer and fall were quite warm and quite dry in Western Colorado. And so that raised the question of whether or not these dry antecedent soil conditions are really to blame for these below average stream flows that we're seeing in April through July. I'm so sorry. Can you hear my dog in the background? I hope the background noise isn't too bad.
You're good, Peter.
Okay,
We haven't heard him yet. We'll welcome
keep
him if we see
plugging
him
away.
on
I
screen.
think the aeration guy came here, and our little Shih Tzu Bichon Frise mix is not happy about it. But I'm just going to keep going here with the dry soils that we saw. You can kind of think about this like a budget where our snowpack each year is like our income. Recharging soil moisture is kind of like paying the bills, and the runoff is kind of like your spending money, where you might think that if you have 80% of or if you have lower than normal soil moisture, then you have higher bills to pay. So even if you have 100% of normal income, you might not end up with 100% of normal spending money. So that was one of the things that people were looking at. But I'm going to argue here with a case study that we did that, in fact, even though soil moisture was a piece of the puzzle, the bigger piece is actually what Paul alluded to and what happens after April 1st, where I'm going to be showing the results that are part of a paper of a case study we did where we made statistical water supply forecasts for the major river basins in Western Colorado in 2020 and 2021. First, just based off of the precipitation that we saw from October 1st of the previous year through April 1st when these forecasts are issued, and the snowpack that we had on April 1st. And then I'm going to show how those numbers were affected when we added in the soil moisture data from a model that NASA uses, how that affected our streamflow numbers. And then what happens if we were to add in the temperature and precipitation data from the remainder of the season in those 2 years? So what if we were to add in April through June, both temperature and precipitation conditions across these basins? How does that impact the statistical water supply forecasts that we made? Okay, so here is a table from that case study. We're going to focus on just the bracketed rows for now, and you don't have to worry about these abbreviations. I'll get to those in just a minute. But the top line is looking at the forecast numbers we had in 2021 from precipitation and snowpack only. And then the second from the bottom here that's also in brackets is the observed April through, actually these are April through August runoff numbers, but very similar to April through July. And we see that for the Colorado River at Cameo, if we look at just the precipitation and snowpack in that basin, we are overestimating things. And if we step through Gunnison at Grand Junction, Yampa at Maybell, and San Juan near Bluff, for each of these basins, we were overestimating the runoff just based on precipitation and snowpack alone. Now, that's VWC plus GW. That just means we're adding in the soil moisture and groundwater information that we had. And you can see these forecasts, they got a little bit better, marginally better, but still in every case except for the San Juan near Bluff, Utah, which actually ended up with some wetter conditions during the spring. In all three of the other cases, we're still overestimating observed runoff. But then if we add in what we know about April, May, and June precipitation, we see if you compare the numbers in the top bracket to the numbers in the bottom bracket, they're actually quite close. And so by addressing these two sources of error, both the very dry antecedent soil moisture conditions, but also the really dry precipitation conditions in 2021 after April 1st, you end up with pretty close numbers. And I think this is one of the things that skewed things in the case of 2021 is that April was actually a record dry April for Western Colorado in 2021. All right, this is important to think about because climate change is changing our water supply. So I just wanted to show two quick slides about that from one recent study that our office put out that you can learn more about at climatechange.colostate.edu. Here we're looking at the recent trend and projected future trend from 36 different climate models in different elements of our water cycle as our temperatures continue to warm, where we see spring snowpack is getting lower with medium confidence because there's still quite a bit of uncertainty in what precipitation will do. Runoff is becoming earlier with high confidence because that's more temperature dependent, and we are very confident that things are continuing to warm. But then annual stream flow as well with these warmer temperatures and shorter snow seasons is moving a little bit towards the lower end as well. So just understanding how all these pieces are changing as they fit together with climate change is very important. One graphic that kind of illustrates that nicely is this graphic here, where we're looking at simulations of future climate from 36 different models. And we're looking at the difference in those simulations between the middle of this century and the end of last century, or comparing 1935 through 2064 to 1971 through 2000. The x-axis here is the change in temperature, and you'll notice zeros all the way on the left. So they're all showing a positive temperature change over that time frame. The y-axis is the precipitation change, where the models are showing, some models are showing more precipitation, some are showing less. Thankfully, they don't all show us getting drier. But the circles show the change in stream flow for the Colorado near dot zero. And the red circles show where the stream flow gets lower. The blue circles show simulations where stream flow actually increased. But what I want to focus on is this number of simulations where precipitation actually increases, but stream flow decreases. So if your temperature's warm and your snow season's shortened and your water cycle changes such that more of the precipitation you receive in winter either evaporates directly or only filters into the shallow soils, you would need a commensurate bump in precipitation to make up for the amount of water you lost to just having higher temperatures. So that's just definitely something that we are thinking about going forward. So just a couple takeaways, and then I will hand it over to Elise. April 1st snowpack doesn't tell the whole story. If we're looking at April through the July runoff, again, Paul covered that very nicely. Both our antecedent precipitation and soil moisture conditions are important, as well as subsequent conditions or what happens after April 1st. Our warming climate also is changing our hydrologic cycle. So it's important to understand things from more than just a snowpack standpoint. And then if we look at years like 2021, some of the years that we've had recently, both the pieces of what happened before the snowpack season and what happened after are very important. So I'll leave it there and hand it over to Elise.
Sorry guys, my screen share is being finicky. There we go. All right, thanks, Peter. I'm Elise Osenga. I manage Aspen Global Change Institute's Roaring Fork Observation Network, or IRON. This is our long-term research program that's dedicated to understanding hydrology and ecology in mountain systems through the lens of soil moisture and in a way that supports decision makers locally. So Peter gave you kind of a broad overview of the role of soil moisture from a modeled perspective. I'm going to give you a quick glimpse into that same topic from the observed data perspective. Our network consists of 10 stations that are spread across the Roaring Fork watershed, which is located in western Colorado and is a headwaters for the Colorado River. These stations are meant to represent the variety of different elevations we have in this area, as well as different ecosystem types here. Every 20 minutes to every hour, they measure soil moisture at 2, 8, and 20-inch depths, soil temperature at an 8-inch depth, air temperature, relative humidity, rain, and snow depth. We're looking at a lot of different things with our data, but we recently got into this whole snowpack runoff question in 2021. So following that year where we had this mismatch between anticipated and actual runoff, this was a discussion where we began to have questions around, can observed in situ soil moisture data like yours actually be used to help us better understand what runoff might be? So in 2022, we received funding from the Colorado Water Conservation Board and the Colorado River District, thanks you guys, to start digging into this question in an exploratory and preliminary way. We are currently in the very midst of this project, so we don't necessarily have a lot of findings yet, but I did want to share some of our initial findings in relation specifically to this question about the relationship between soil moisture and runoff efficiency. So for this particular data analysis I'm sharing right now, we defined runoff efficiency as the total amount of precipitation in a water year that makes it to the streams and rivers. And we compared that runoff efficiency to November average soil moisture for 7 of our sites in the Roaring Fork watershed. So what you're looking at here are R-squared values. Just in case it's been a while since anyone's talked about R-squareds, this is a mathematical way of saying how are two things related. An R-squared of 1 would mean you have this perfect relationship where if your soil moisture changes by a certain amount, you know that absolutely your runoff is going to change by a certain amount as well. An R-squared of 0 means there's absolutely no relationship between these two things. For 5 of the 7 sites that we ran this test on, there was a very, very weak relationship between those two things. There's a lot of reasons for that. Email me if you want to get into the nitty-gritty details as to why. But it wasn't necessarily this clear one-to-one that one might expect. For 2 of our sites, however, Glenwood Springs and Sky Mountain, we got R-squareds of around 0.65, which is actually pretty good for this type of analysis. Why those 2 sites performed better, again, is a complicated question. Sky Mountain does have our longest period of record for any of these sites, and it also has a loamy soil, which behaves in the way that you'd expect soil to behave with water, versus somewhere like Brush Creek or Spring Valley, where it's clay and the water's binding really tightly, or Smuggler Mountain, which has a nice long data record, but the water just shoots through it like a sieve. And even for our longer data records, we do only have 10 years. So we have a limited spread of, when we're doing this analysis, years that are really dry versus really wet soils. So all this being said, the key takeaway from this initial dig in that we did to the data is essentially that this relationship between soil moisture and stream flow is a lot more complex than was previously supposed. That's not to say there's no relationship between these two things. It's just to say that we maybe need to be thinking about this from a more nuanced perspective, where we're taking into account things such as what depth of soil are we considering for the soil moisture we're using as antecedent? Is November really the right time of year to use for antecedent soil moisture? I have a lot of thoughts about that. Email me, I'll put my email up at the end if you want to get into those weeds. Also, how representative is this data? Is the model data actually representing what's happening on the ground in these areas, especially when they have complex terrain? Is the observed data, which is taken from a single point, actually representative of the landscapes around it? And finally, are there thresholds or tipping points? Peter didn't have a lot of time to get into this, but in the really, really dry years of 2020 and 2021, for the model data, it did seem like there was more of a relationship to improving forecasts when there were these really, really dry antecedent soils. So if we're moving into a warmer climate, and if we are consequently seeing drier soils in the fall, is there a threshold at which that really is going to matter when we're trying to do forecasting? So with all these caveats in mind, I am going to wrap up with what I think is maybe a question a lot of you might still have, which is, all right, you know it's complex, but still, what was our soil moisture for this year? So this is for the Roaring Fork watershed. The base maps down there are from the CBRFC, and that's showing percent of average soil moisture for our current water year, so November 2023 on the right, and then 2020, just to give us a reference point for really dry year on the left. And we are looking better than we did in 2020. That's the good news. In the Roaring Fork, in the lower areas of the basin, we're very close to average or even above average. Some of those higher elevation areas are a little bit drier than average. And then in just a quick and dirty way, those raindrops that you see sitting on there, that is percent of saturation for soil moisture at each of my individual sites. It actually lines up quite well with the model data. I was very pleased about that. And what we're seeing is very similar. It is close to being moderately wet, a couple places that are higher elevation being a little bit drier. And these are patterns that are showing up across Western Colorado for soil moisture for that November 15th antecedent condition, where we are definitely wetter than we were in 2020, but there are some southwestern parts of the states that are still looking pretty dry. So that's just a quick overview of how our data aligns with what Peter and his co-authors were seeing. And I'll just wrap up. I'm going to jump back to that in a second, but by saying thank you to the partners and collaborators without whom this network would not exist. All right, thank you.
Thank you so much, Elise and Peter, for that thorough dive. And it's funny, it's just not really the answer I want. I want a simple answer. I want a direct correlation. I want all those R squareds to be 1, because living with this constant level of uncertainty is just, it's frustrating for water users. It's difficult for decision makers, but it is definitely the reality that we are living in. So I was going to follow up with just a few questions, I think, and I think Caitlin might have had some as well. But I'm going to jump back to Brendan. So Brendan, you got to turn your camera back on. I got a question for you. Going back to the dust on snow events, I was wondering if you could just dive in a little bit more to the physics of why dust on snow is so impactful. Or, well, I guess maybe it's not as simple. We're learning that it's not a one-to-one correlation, but what's the physics behind that?
Yeah, great question. I think as the dust sits on it, just that dust can really just capture and hold on to that heat, that solar warming from the sun, and can just speed up the melt of the snow. So that snow to flow goes a lot quicker when you have that dust and that thermal heat sitting on that snowpack. There's been some great pictures where you can see a whole snowfield that's covered in dust, but there's one spot where this snowball rolled down the mountain is in the middle, so it's all fresh snow, and you can see how everything just melts around it as this fresh snow kind of stays on top. And that was a really compelling picture for me of kind of understanding what's going on that you can't see on the whole scale, but you can see in just a little aspect of what's going on between the difference of how that that dust on snow really does impact that snow melts and speeds it up.
Is that, I think, albedo? Is that the word that I've had to learn?
Mm-hmm.
Nice. Well, Paul, I have a question for you in general, and I don't mean to put you on the spot here, but as someone who is definitely interested in river recreation, I've pulled a few permits, not as many as I might have liked. But I was wondering if you could just give us a broad overview of what we might be seeing in the rivers as far as runoff this season.
It's hard to say, when the best time would be to go rafting or anything like that, especially because I am not one that gets on the rivers too often to do that sort of thing. But last year was such a great year that we recovered quite a bit as far as like our regional soil moisture goes. And we expect a fairly efficient runoff this season as a result. That being said, how that water comes off is going to be really contingent on temperatures. Last year was so perfect because we would get these warm-ups and cool-downs, and it really kept the flood threat to a minimum. We could have had a much worse flooding year last year if we had just increasing temperatures and things like that. That being said, I think river levels in general, we're expecting them to be near average throughout the season. That could definitely change if we say get a really fast and rapid warm up. You might see a big slug of water come through more quickly at the beginning of the season. But in general, I'd say it's fair to assume near normal conditions throughout the basin.
Thanks. And I'm looking through some of the questions that you all have entered into the Q&A. Thank you so much. Quick question to answer. Why is November used to determine average soil moisture, assuming that it has something to do with the beginning of the snow season or the water year?
I can.
Is that, oh, sorry.
Oh, sorry, we can
Let's
maybe
do
just
Wes and
all
Paul.
panelists. Yeah.
Well, for us, the reason we use November is because that's when irrigation typically starts to shut off, and that's when stream flow conditions have typically gone to like base flow. So we can infer a lot about the soil moisture from that before the gauges freeze.
And then Elise, a question here is, are the Roaring Fork soil moisture monitors all placed on the same aspect? So that means the direction of the, not for you to explain this, but for the rest of the audience, the direction that the hill is facing. Have you seen any trends in vegetation around the monitors and soil moisture? And I guess, would that impact them?
Yeah, so they are not all on the same aspect. I can understand why that was asked. We were limited in sites by where we could get permissions, as well as trying to capture different ecosystem and elevation types. So they do vary a little bit. In terms of vegetation, we have done some baseline surveys to see species type and abundance up there, and we are planning to redo those. So far, no changes, but it's also only been 11, 12 years since the first site went in, so. We do see huge variation year to year in dry years, though, in terms of what blooms and what doesn't.
Okay, so for Peter, says you provided a rough correlation of temperature increase to a corresponding increase in moisture to maintain runoff volume. Is that relationship over the entire April through June period as an average, or would that be compounding month to month? And I'm assuming you understand that question perhaps a little better than I do.
Yeah, that's a good question. So I think the big thing to watch out for there is that if temperatures continue to warm and we continue to see these longer, warmer, drier summers, well, I shouldn't even necessarily say drier because that's going to continue to be highly variable. If we continue to see longer, warmer summers, then we're going to see more circumstances where we start the snow season with soil moisture levels that would be considered below normal by current standards. And so that's something that you have to account for when you look at the next year's runoff, is that you're starting with, by what we would call by current standards, a deficit in root zone soils.
Thanks. And Caitlin, feel free to jump in here too if you have other things that you wanted to address. So we're looking at a question about general higher level patterns like El Nino. Are those taken into account for projecting precipitation? And I think that was touched on a little bit. Paul, you mentioned that you guys don't really account for it, but could we maybe come back to that and see, I think we're moving into a potential La Nina cycle. Does that matter to you? Do you guys even care?
We do look at it, but we've done a lot of correlation analysis. We've had really wet La Ninas and really dry El Ninos and everything in between. There doesn't really seem to be a correlation in the upper Colorado River Basin. We do incorporate El Nino and La Nina information in our lower basin forecasts in Arizona, just because there is a little bit more of a correlation there. Typically, we only do that for the first couple months before, the snowpack accumulation and that sort of takes over as the primary driver. But again, even in the lower basin, we've had there's a pretty good amount of variability. So yeah, we don't take it into account. But one thing we do is we make all of our traces available. So for instance, if a water user wants to do their own analysis and pull out the El Nino years and look at how that spread changes, they're welcome to do that. You're muted, Lindsay.
Thank you. Thanks for that answer, Paul. Brendan, you touched a little bit on this in your presentation, that there was a bit of a difference between what the Front Range got as far as snowpack and what we saw here on the western side of the Continental Divide on the western slope. Could you go back and mention, is that a significant difference? Are we looking at a lot more snowpack on the Front Range flowing down the Platte and the Poudre, or where are we with that now?
Well, I think according to average, they're both pretty similar. Where both the Front Range and the West Slope basins are all near average. So I think overall we're there. I think I was referencing some really big storms that occurred earlier this year, where there was some massive snow deposits. But the Front Range municipalities all really experienced. And so I think they had some bigger storms that came in that kind of had some maybe bigger steps in the snowpack rather than the more gradual that we've seen here on the West Slope.
Is that going to affect stream flow directly, or in the shared water that's drawn across the Continental Divide from the headwaters of the Colorado River that serves those Front Range communities? Does that change that relationship in any way?
Well, I think it certainly impacts some of the stream flows when you get those storms especially in lower elevations. That's going to melt off a lot sooner. So you're going to see some fluctuations in those streams. And one of the references that I had earlier was that following those big snowstorms, there was a melt, and that definitely provided a lot more flow through those rivers for those water users and maybe reservoir operators to fill the reservoirs in priority when typically they may not have been able to do that with such a big storm that came through and a melt that followed. So yeah, I think it does does impact. It depends on that elevation of the snow and when it comes and when it melts. And so as has been alluded to several times today, it's all dependent upon what the future weather patterns really are. Do we get these really warm 100-degree days in April and May? That can have a big impact on when that runoff comes. Or Paul was referencing last spring when we had these really cool spring with a lot of cloud cover, a lot of maybe rain or snow events that just kind of helped really slow down that snowpack and extend that runoff to a longer period, like over a month of some peak flows that we witnessed here at the lower Colorado River. So it all depends, and we'll see how it shapes up.
I have a related question about late season weather forecasting. I wonder if Peter might be able to speak to any, I don't know if folks are making advancements in late season forecasting, and perhaps a question for Paul, if anyone working on modeling is looking at incorporating that into runoff forecasting.
Yeah, unfortunately, late season forecasting where you're looking at trying to kind of guess what's going to happen in April through June is just really difficult. Some of the ways that we would think to look at that are looking at things like El Nino versus La Nina and how that correlates to seasonal precipitation. Because unfortunately, our numerical weather models that do a really good job at the first 1 to 7 or even 1 to 10 days kind of descend into chaos after that. So it becomes really difficult to forecast what your precipitation is going to look like relative to normal for a 3-month period. And then, like Paul said, El Nino, La Nina doesn't necessarily give you as much skill as we would hope in our area of the country, whereas some areas it does a little bit better. One area where I think people are making a little bit of headway is looking at what's called the Madden-Julian oscillation, which is a somewhat predictable cycle in tropical thunderstorm activity that has ripple impacts throughout the rest of the globe. So when that oscillation is in certain phases, it tends to be a little bit wetter or drier here within the next week or two. And I've seen that some research is making headway, doing a little bit better at forecasting, say in that 2 to 4 week time period, with using some of the information from the Madden-Julian oscillation. But subseasonal to seasonal forecasting definitely is still an open research area and not a solved problem.
Yeah, and I'll just tack on that we're actively working with the Climate Prediction Center and other folks to come up with longer range forecasts, and through the Colorado River Climate and Hydrology Work Group, we've got methods to evaluate it. So far, we have evaluate new approaches and new methods. So far, nothing is really playing out, but we're definitely interested, and folks are investing in it.
And I think time for just one final question from Robert Cicada. In farming, we are very aware of the frost level in the soil. How does this impact stream flow, quantity, and timing? And I'm not sure if that's Paul or Peter.
Well, maybe Peter has a better answer than I do, but our model, every day we're trying to capture like what the soil moisture states look like, and what the situation is on the ground. So we rely a lot on gauge information. When we start seeing the gauges begin to unfreeze, and start providing reliable data, so we rely a lot on our model to tell us that kind of thing.
Yeah, I don't have a better answer than that. That's a great question, Robert. I think that I can probably, follow up later and hopefully find something or someone that gives you a better answer to that question.
Well, thank you, everyone. I think we're about out of time, but it's been really wonderful, great presentations. Thanks to our partners at the River District, and all of our great speakers and everyone who's been on the line asking wonderful questions. Lindsay, I'll turn it over to you.
Yeah, thank you so much, speakers, for your time and your expertise. You'll see we are dropping their emails in the chat. So if we didn't get, to your question today, please feel free to follow up with them. And if you just can't get enough of river information and you want to participate more in some of the Colorado River District outreach events, we are still working our way through the State of the River series, and we have 4 more to go. We'll have a public presentation in the town of Rifle on May 7th, up in Granby on May 9th. Then we're moving to Silverthorne for May 23rd and wrapping up the year in Edwards on May 29th, where Peter will actually be joining us again. So those presentations focus a bit on this information, the outlook and the overview of rivers coming up. It also focuses on the work of the River District and some of the interstate issues. And you get to hear about the exciting local projects, people who are water users in your community who are approaching and solving these problems that we're all facing. So again, thank you all so much for your time, for your participation today. There will be a recording available on our website, and it should be also emailed out to all participants. Thank you all very much.